Here we have an example of the quotient of two radicals. So they are separate. And this is one where I am going to want to actually simplify them together before I start trying to break the radicals apart. Because currently I have a radical in the denominator, and we know that that is a big no-no. So we want to try and either simplify it so that it becomes a perfect square, or simplify it all together so it disappears. So I'm going to rewrite this as 30x cubed y squared over 12xy. And it might help you for visualization purposes to just totally get rid of the radicals for a second and just look at this problem right here. So this is like going back to your exponent rules and everything like that. So if we break this into terms, I see that 30 and 12 have a few things in common, okay? So they have 2, but if I take a 2 out of the 12, it leaves me a 6. That's not a perfect square. I see 6 is in common, but if I take a 6 out of the 12, leaves a 2, which is not a perfect square. So then I see if I take 3 out of them, if I divide 12 by 3, then it will leave a perfect square. So I can take 3 out of this, so 30 divided by 3 is 10. 12 divided by 3 is 4. So now I have 10 over 4. Remember, I know it can simplify more, but we really do want it to have a perfect square in the denominator. So it's okay that it can go more because we want this to be a perfect square so that when we take the square root of it, it doesn't have a radical anymore. And then looking here, x cubed divided by x, more x's on top. 3 minus 1 makes it x squared. And then y squared divided by y is y. Okay, so now let's take it back to where it needs to be. So this is the square root of 10x squared y over the square root of 4. Okay, and now what we can do is we can go through our properties to kind of find the perfect square. So 10 doesn't have any perfect squares in it, but x squared does. So I can write this as x squared root 10y, because y doesn't have any perfect squares. And then 4 is a perfect square, so over the square root of 4. And kind of going backwards, sorry here, the square root of x squared is x root 10y, and then the square root of 4 is 2. Okay, and I just want to point out one thing about that answer. So we had x square root of 10y over 2. You have the same rules here as you did for multiplying. So a lot of people look at this and they're like, oh cool, 10 divided by 2, I can make that 5. But you cannot, because you can only divide inside divided by inside, or outside divided by outside. So where's my red that we can use again? You cannot do inside divided by outside. And then you also cannot have radicals in the denominator as your answer.